Right, hello Year 7. So today what we're going to do is we're starting a new topic and it's called classification. Okay, but before we do that, we need to go through your test. So last lesson, while I was in school, you did this test. I'll just pause the video for a second while you get this out and then I'm going to go through the answers. Okay, so bear with me because what we're going to do is flip through the answers like this. So first question was, from the food web, give two names of two animals that eat krill. The answers you should have had were crab-eater seal, cod, or squid. If you put fish, that's fine. Seal is insufficient. Right, part B. Which word describes the plants in a food web? They are producers. And then which word, krill are small animals that eat tiny plants. Which word describes krill in a food web? It was herbivores. Okay, and there's your answer. Okay, next one. Crab-eater seals eat krill. Fishermen catch large amounts of krill from the sea. How would a decrease in the number of krill affect the number of crab-eater seals? So, the number of crab-eaters would go down or decrease. There'd be fewer seals. They would all die as insufficient because they probably wouldn't all die. Some would die, but not all. Okay, next one. Look at the food web. Leopard seals also eat krill. A decrease in number of krill would affect the crab-eater seals sooner than it would affect the leopard seals. Give a reason for this. Okay, so leopard seals eat other animals as well as krill. They eat other animals or another source of food. They have more food is insufficient. That's not quite right. Leopard seals could eat cod or fish or squid or penguins. Crab-eater seals, or they only eat krill. So if you mention that the crab-eater seals only eat krill, that's fine. Okay, so give yourself a mark out of 6 for question 1. Question 2. The drawing shows a plant called Tillandsia. The leaves of this plant absorb light. Why do plants need light? Okay. To make food, glucose, or sugar, or photosynthesis, or to grow. Any one of those answers is fine. Tillandsia plants grow on the high branches of trees in the rainforests. These plants cannot grow well on the lowest branches. Explain why. So think what they're not getting on the lower branches. There is not enough light, or there is less light, or light can't reach them. Anything like that would get you the mark. Tillandsia plants do not have roots, hairs on their roots. What two substances do most plants absorb through their root hairs? The answer you were looking for was oxygen, water, minerals, or nutrients. But really, probably water and minerals. But you could have had oxygen actually as well. Which diagram shows a root hair? It is B. Okay, you actually had all these 1, 2, 3, and 4, but it was B. Okay, so that was out of 5. So give yourself a mark out of 5 for that, please. Question 3. The drawing shows a mole. Moles dig tunnels through the soil. Give one way a mole is suited for digging through the soil. Okay, now you can have a couple of answers here. It has large, wide hands or paws. Paws are like shovels. Big, strong feet. It has a pointed head or face or nose. It's streamlined. It has strong claws, sharp, long claws or nails. So it's got claws just on itself isn't enough. Eyes are protected, or the eyes are deep within the fur. Okay, so if you have a look at the picture again, you can see how it's protected from underground. Okay, moles are part of the food chain shown here. So you've got some leaves, then a worm, then a mole, then an owl. Okay, which living things in this food chain do moles eat? It is, of course, the worm. Which living thing in this food chain is a predator of moles? It is, of course, the owls. So some people use mole scarers to get rid of moles from their gardens. Two different mole scarers are shown below. They both produce sound to scare moles away. Where does the energy come from a solar powered mole scarer? It is the sun, okay, or light. It's obviously solar powered. It's just one reason why using a solar powered mole scarer instead of a battery powered mole scarer. Well, best reasons, the batteries would have to be replaced in a battery one. Solar power is free. Solar power does not run out. It's cheaper to run because you don't have to keep buying new batteries. So any answer like that would be fine. So some gardeners use poison to kill moles. It's just one reason for using a mole scarer rather than the poison to get rid of moles. So it does not kill the moles. It's humane. It does not harm other animals because poison might kill other animals, including us actually. Poison kills or hurts the moles, whereas the mole scarer doesn't. Poison kills or hurts owls, predator or other living things. So basically the poison might accidentally hurt or target other animals. Poison can enter the food chain. So poison can move up the food chain and ultimately end up in humans. So give yourself a mark out of 6 for that. So question 3 was out of 6. Give yourself a mark out of 6. So question 4, the drawing shows a horseshoe bat. There it is. In an investigation, Val counted the number of insects a horseshoe bat ate. Her results are shown below. So you've got 35 beetles, 10 cockroaches, 40 moths, and 15 sort of other insects. Val used a number of insects to draw a pie chart. Write the letter of each insect in the correct section of the pie chart. So you've got to have a look at these numbers, think which relates to which. Okay, so your answer was this. B, D, C, A. Okay, so if we actually go back, cockroaches, other insects, that was dung beetles and moths. Okay, so it should have been there like that. Dung beetles eat dung animal droppings. Why are there lots of dung beetles in fields where cows are kept? Okay, so this was worth 1 mark. Now, the reason for this is because there's plenty of dung, food. Cows make the dung. Okay, so anything like that, basically this idea there's plenty of food for them. Why do horseshoe bats live close to fields where cows are kept? Well, essentially because there are plenty of dung beetles there for food. Okay, there's lots of dung beetles for the food. C, insecticides are used to kill insects. What will happen to the number of horseshoe bats if insects are killed? It will decrease or go down. And give one other reason why the number of horseshoe bats might change. So is there any other reason why the number of bats could just for some reason change? Well, there could be a change in climate that isn't suitable for them. Maybe there's some new predators that eat bats, possibly a new disease. Their habitat for roosting might be destroyed. There's an increase in the food supply, so maybe their numbers go up because there's more food available. Maybe if the insecticides are not used anymore, there'd be more food available. Insects become resistant to insecticides. Now, this is an interesting one. If the insects become resistant and are no longer killed by the poison, the insecticide, there'll be more of them, and so there'll be more bats because they have more prey to support them. So give yourself a mark out of 7 for that question. Question number 5. Rhododendron plants grow bigger and faster than other plants. The drawing below shows a man cutting down a rhododendron plant. Scientists think the rhododendron roots might produce a chemical that stops other plants growing nearby. Why does this help the rhododendron to grow? Okay, so question 7, because it reduces or stops competition, stops other plants taking water or minerals. They get more water and minerals, nutrients or space. Okay, give another reason why hardly any other plants can grow near the rhododendron. So, not enough light, and not enough water. Essentially, the rhododendrons grow very fast and very big. Okay, so they block off all the light so other plants can't get light, but also they take up all the water from the soil and dissolve in the water, of course, are minerals. So you could also have that, okay, because there's none of the other plants getting the nutrients from the soil that they need. Okay, C, the drawing shows an insect called a weevil. Weevils feed on the leaves of rhododendrons. Draw a line from the rhododendron box to the word that describes the rhododendron, and draw a line from the weevil box to the word that describes a weevil. So if we just go down, there's a rhododendron, you need to draw a line there, and a weevil there. So the answer would be there. Rhododendron is a producer, and a weevil is a herbivore. Oh, I just realised I forgot B, yeah. After the rhododendron and their roots are cleared away, there will not be any of the chemicals in the soil. What will happen to the number of plants growing there? Sorry, should have included that. It will increase or go up. Okay, so that question was out of 5. So give yourself a mark out of 5. That last one was 2. You had to get both right. Okay, question 6. The diagram shows the annual flow of energy through part of a meadow. So this one was quite tricky. So this is the amount of energy, 6.3 times 10 to the kilojoules per meter squared. So a lot of energy. So lots of energy going into plants, absorbed by plants during photosynthesis. Some is lost to the surroundings, doesn't all go to plants. And then plants, they give out some energy to the surroundings. But of that amount of energy, 8,000 goes forward, 300 goes to herbivorous birds, herbivorous animals, and herbivorous arthropods. So that's birds, mammals, and basically insects. Use information in the diagram to calculate the amount of energy absorbed by plants during photosynthesis each year. Right, so you have to have a look at the graph, look at this diagram. So it was 10,000. How do you come to that? Well, let's go and have a quick look. Okay, so this is how much energy comes in, but this shows you how much is actually taken in by the plant. Now, 8,000 of it is used by the plant, but 2,000 is taken in but lost to the surroundings because plants give off energy as well. So the total was 10,000. Right, name the process which accounts for the annual transfer of 2,000 from the plants to the surroundings. So what is it that's giving away this 2,000? Well, it's respiration. So energy, they're using the energy, making food, but they're also using that food. They're giving that energy off. Okay, next one. Calculate the percentage of the bird's energy transferred to the surroundings. Okay, now this is tricky, but they take on board 300 kilojoules. Now, 297 of that is given away to the surroundings. Only 3 is used for growth. So what you need to do is work out percentage. Now remember, 100% is everything. So you can see they lose most of it. Okay, so the way you do that is 300. Apologies, just had to get the calculator up there. So the way you do it is you take what's lost to the surroundings, 297, and divide it by what went in, 300, and that gives you 0.99. And then to turn it into a percentage, you times it by 100 because 100% is everything. It's 99. So if we look at our answer, 99% of what is taken in by the bird is lost to the surroundings. Now, the arthropod transfers 84% of their energy to the surroundings. One difference between birds and arthropods, which causes the birds to transfer a higher percentage of energy to their surroundings. Well, think about a spider, like an arthropod or an insect, okay? And then think about a bird. Key thing is that birds have a higher body temperature, they're warm-blooded. more losses of energy in exhaled air from the skin, higher metabolic rate. Basically, birds are warm-blooded and use more energy. So they give off much more of their energy to the surroundings. Okay, question 3. Transfer of energy from plants to herbivores is less efficient than the energy from herbivores to carnivores. Suggest why the energy from plants to herbivores is less efficient. Now, this was a tricky one, but plants contain a higher proportion of indigestible material. That means if they eat like plants, they can't digest all the bits. They just have to go through it, go through their bodies, so they don't actually get the energy from it. Plants contain cellulose, or plants contain lignin. Now, the idea is the same. All of these, they can eat them, but they might not actually get any nutrients from them. Okay, so that was the answer to that one. The energy efficiency of a meadow plant is the energy used for growth as a proportion of the energy from the sun. Calculate the energy efficiency. Right, okay, now this is again another calculation. Okay, so it says the energy efficiency of the meadow plants is the energy used for growth as a proportion of the energy from the sun. Calculate their efficiency. So this was the energy going in from the sun, and this is what they were actually able to absorb. Okay, so how we would work this out, if we take the amount that was absorbed, the amount the plants actually got, 8,000, so there that is there, and we divide that by the amount of energy coming in from the sun. Now, for those of you that can do maths quite well, this is a good question for you. 6.3 times 10 to the 6. So 6.3 times 10 to the 6 is that number, 6,300,000. Now, that gives you 0.000129. Now, you might think, oh, I'm on the wrong track here. But if you times that by 100 to get the percentage, you get 0.126. So you round it up to 0.13, which is your answer, 0.13%. Okay, right, last question, I think. Just quickly go down. Some fields are being sown with oilseed rape. Seeds from oilseed rape plants can be used to produce diesel oil. The energy efficiency of an oilseed rape field is similar to that of a meadow. The energy efficiency of a solar cell is approximately 10%. Use this information to suggest 2 disadvantages of using diesel oil from oilseed rape as an energy source instead of using solar cells. Okay, so diesel oil can be used in vehicles. Oh, sorry, no, it's got this one up here. Lower energy efficiency or more land needed to produce the same amount of energy. Okay, much of the energy in the oilseed rape plant is wasted, or extra energy is needed to make diesel from seeds. Okay, and part 2 is just one advantage of using diesel oil from oilseed rape as an energy resource instead of using solar cells. Okay, so one example, well, actually there were several examples. Diesel oil can be used in vehicles, can be transported easily, can be used as night, whereas solar can't, obviously. Diesel can be used in all weather conditions, and diesel oil can be stored. So that was out of 9, so give yourselves a mark out of 9 for that. I should point out that was the hardest of the questions because it involved quite a bit of maths. That was a real challenge one. And then finally, question 7. I think this is the last one. Yes, okay. So question 7, you've got a food web here. 1 year, the snail population increased in the grassland area. How could an increase in number of snails cause the caterpillar population to increase? So, blackbirds eat more snails, so they're eating fewer caterpillars. So therefore, caterpillar numbers go up. Snail poison can be used to control the number of snails. After some time, each owl contains more poison than each snail. Explain why each owl contains more poison than each snail. Right, so blackbirds eat the snails, and then owls eat the blackbirds. So the poison passes up the food chain or becomes more concentrated. A word you might get used to is called bioaccumulation. Basically, the poison accumulates in living things. Poison accumulates, animals can't get rid of the poison, or the poison just stays there, persists. Owls eat a large amount of poison that can be passed up the food chain. I'm afraid you can't have, though. Right, C. A scientist wants to record the number of dandelion plants in the grassland area. Describe how they could use a 1 meter square quadrat to estimate the number of dandelions growing in the area. This was quite a tough one, so don't worry if you got this one wrong. Okay, so throw a quadrat randomly and just count the number of dandelions. Take several readings to find an average and multiply that number by the total grassland area. That was tricky, and unless you knew how to do that, you probably wouldn't have got that one. So don't worry too much if you didn't. Right, last question then. The table below shows the population or the number of for one food chain from a food web. So you've got 200 dandelions, 20 rabbits, 4 foxes. Complete the period of numbers on the graph paper to show below to represent the food chain. Label the pyramid with each one. So there are your dandelions. Now you need to think, got 200 dandelions. So how wide should it be? Each one is worth 10 organisms. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, 180, 190, 200. Okay, so we know we've got 200. So if each square is 10, how many rabbits, how wide should your rabbits block be? And how wide should your foxes block be? It should look like this. 2 blocks for your rabbits, and then barely half a block there for your foxes, and that was out of 7. Right, so there's quite a lot there. So if you need to check that again, you can pause and go back, okay, and then you can send me your final score a bit later. Okay, everyone, so the test was out of 45, so you can email me your scores or post them up on assignments if you don't mind other people seeing them. Right, so on with today's lesson. Now, what we're doing is we're looking at classification. And so by the end of today, all of you will be able to describe the characteristics of the animals in something called vertebrate groups. Most of you will be able to use the characteristics of different animals to sort them into groups. And a few of you will be able to explain why certain animals are in different vertebrate groups. So, a couple of things to begin with. Can you remember the 5 vertebrate groups? Now, you would have done this at primary school, so hopefully you've got some idea of what they might be. So, pause the video quickly and see if you can remember the 5 vertebrate groups. Okay, so when we think of animals, we can classify them into 2 main groups: vertebrates, those that have a backbone, and invertebrates, those that don't have a backbone. Now, 5 vertebrate animal groups that you should be familiar with are these ones: mammals, reptiles, birds, fish, and amphibians. So what you are going to do is, there's a YouTube clip here, and actually there's another one just up here. I'm going to put these in assignments. I want you to pause the video and watch these now, and then we're going to come back and we're going to try and classify some different animals. Now, this is a bit of an introduction because we're going to do a bit more with this next week. So pause the video now, go to assignments, and watch those 2 videos, please. Okay, so what I'd like you to do is, now you've watched the 2 videos, is try to complete these sentences. So a vertebrate is, and an invertebrate is. Okay, and then can you think of any of the subgroups within vertebrates, even though we've already identified what they are? Okay. Okay, now your last task for today, which should take you probably about 15 minutes or so, is I would like you to draw up a table in your book like this. So in one column, you've got the name of the 5 vertebrates, so mammals, birds, reptiles, amphibians, and fish. And then in the next column, they're identifying features. Now I'd like to write down what it is about those types of vertebrate that only they have. So for example, in mammals, you could write things like has mammary glands, gives birth to live young, have fur. All these things you could put in there, but I want you to identify and research yourself what the identifying features of each one are. Okay, and then once you've done that, snap a picture of it and upload it to assignments, or you can do it onto a Word document and upload it to assignments that way. Okay, so things that you should actually have done today is gone through your answers for your test from last lesson and submitted your answers, your score. Then you need to have watched the 2 video clips, and then you are going to research what are the distinguishing features of mammals, birds, reptiles, amphibians, and fish. Looking for about 4 or 5 features within each one in order for you to do that, and that should bring you nicely up to the end of the lesson. Okay, good luck, and I'll be online if you need help.